Example 5 is a mixture of a type 3, which I've highlighted in red, and a type 1, which I've highlighted in blue. And when we have this type, we should be checking to see if the quadratic x squared plus 3x plus 7 is indeed a type 3. And to check for this, what we're going to do is we're going to look at that quadratic and we're going to check for factoring. So in this case, it doesn't factor. If it doesn't factor, then we need to check to see if the discriminant is less than 0. So the b squared minus 4ac. So when we plug the b squared in, we get 9 minus 4 times 1 times 7. We end up with negative 19. So since negative 19 is less than 0, it must be a type 3. So we're going to make note that when we set this up, we're going to be doing that as a type 3 or an arctan type. So I've split this up into its partial fractions, a over x minus 1, bx plus c over x squared plus 3x plus 7, making note that the numerator is a degree less than the denominator, so a is a degree less than, that a constant is a degree less than x minus 1. The bx plus c is a degree less than the x squared in the denominator. So once I've set up the partial fractions, I can solve for a, b, and c. So I'm going to set up a system of equations to do this. Now, there's a few different ways we can do it. We can find zero factors by plugging in x, or we can just get a system of equations equating the coefficients. So I'm going to set this up as a system of equations equating the coefficients. To do that, we're going to expand out the brackets and then combine like terms. So I'm going to expand out the first bracket there. So I get ax squared plus 3ax plus 7a. Okay, so that's expanding out that first bracket. And then I'm going to do the same for this set of brackets. Remember to FOIL this out. So I get plus bx squared plus cx minus bx and then minus c. And that's going to be equal to the original numerator, which is 3x squared plus 4x plus 4. Okay, so I'm going to set up a system of equations to solve for a, b, and c. And to do this, I'm going to equate the coefficients. Okay, so first thing I'm going to do is group my terms. So I end up with a plus b x squared. Those are all my x squared terms. My x terms are going to be 3a plus 3ax plus cx minus b. So we get 3a plus c minus b x, and then plus the constant terms are going to be 7a minus c. And that's going to be equal to 3x squared plus 4x plus 4. So then equating the coefficients, I'm going to make the x squared coefficient equal to 3. So I get this equation a plus b is equal to 3. I'm going to equate the c coefficient, the coefficient on x to 4. So I get another equation here. This is 3a plus c minus b is equal to the coefficient 4. And then my third equation to solve, so that I can solve for all three variables, my third equation is going to be based on the constant term equaling the constant term on the other side. So I've equated the coefficients, and by doing so, I've generated three equations to solve for three unknowns. Now, it looks like it's going to be easier to substitute for C and make the middle expression. So since the middle blue expression has the most variables, I'm going to just replace those variables in this way. So I'm going to get C is equal to 7a minus 4. And then I'm going to replace this c with that expression. And I'm going to replace the b with an equivalent, with another a expression. So b equals 3 minus a. And then I can just substitute for that b, and my new equation will just have a's in it, and then I can solve the system that way. So this new equation is going to look like this: 3a plus, instead of c, I'm going to replace that c with 7a minus 4 minus, instead of b, I'm going to replace that with 3 minus a, and that's going to be equal to 4. Okay, so I'm going to take this equation, just going to do that a little bit neater. I'm going to take this equation, I'm going to solve for a, and then from that equation I'm going to find b and c. So solving this, combining my like terms, I'm going to end up with 3 plus 7 minus negative 1, which is 11. So I'm going to end up with 11a, and then I'm going to end up with negative 4 minus 3. So I'm going to add 7 to both sides to get rid of minus 3 and minus 4. So I get 4 plus 7 is 11. And that gives me an a value equal to 1. Okay, so there's my starting point, a equals 1. From there, I'll solve for b and c. So c is equal to 7 times 1 minus 4. That gives me a c value equal to 3. And then what's left to solve for is just b. So b is equal to 3 minus the a that I solved for originally. And so I get b is equal to 2. Okay, so now I've solved my partial fractions. So at this point, my partial fractions is going to look like this. I'm going to have the integral of 1, a is 1, over x minus 1. Okay, that's going to be that portion. And then the portion that I'm going to need to use arctan for is going to be the bx part. So I'm going to end up with the integral of bx. So b is going to be 2. So I get 2x plus 3, which is c. And that's all over x squared plus 3x plus 7 dx. Okay, now since the red part is an arctan type, the arctan types split up into a substitution portion, and then there's going to be another portion which is going to split up into, which we'll solve as an arctan type. So this is going to generate another part which is an arctan. Okay, so I'm going to integrate the blue one because that's just going to be log. So I'm going to end up with log of x minus 1. Okay, and then to figure out the substitution part, and that's the part we need to do first. We need to figure out the substitution. So we're going to let the denominator u is x squared plus 3x plus 7. And then we need to generate a du. And this du is going to indicate to us how we're going to do the substitution. So in this case, I'm going to end up with 2x plus 3 dx. Well, that part is entirely going to be consumed by what's there. So we're going to end up with 0 left over for the arctan part. So then it looks like this. Let's shift this down a little bit. Okay, so that came from this portion here. Okay, so that's going to be from there. And then plus, using the substitution, we end up with the integral of 1 over, so the denominator is our u, so we're going to go u, and then that 2x plus 3x is going to be replaced by the dx here, sorry, the du here. So all of that gets replaced by du, and because there's nothing left over here from the plus 3, there for the arctan portion, and although we don't need to write it, I'm just going to show this for emphasis, there's 0 left for the arctan portion. Okay, I'm just going to highlight this because this 0 is the part that's left over when we do our substitute, replace our du into that substitution expression. So there is no arctan part of this for the integral. So then, working the rest of this out, I have log x minus 1, which I've worked out for a while, plus this portion now I can use anti-differentiate to log u, plus, and this just becomes 0. So then I have to remember my plus c. Okay, so normally there's some part left over that I can apply, the constant left over, which I can apply arctan to, but in this case there's nothing left, so there's no arctan portion of this. So then log x minus 1 plus the log u, I'm going to replace with x squared plus 3x plus 7, and then we have a plus c. Okay, so there is the integral. I can combine this if you like. You can write this as log of x, the product of x minus 1 times x squared plus 3x plus 7. Okay, either of those solutions is perfectly fine. So this is when we've split up. We have to split up a linear part and a quadratic part, and that quadratic part ended up being an arctan part that only involves substitution. So technically we can just say that that part was substitution.